Ed,
Okay, let me just set everything up here.
do all the things.
Do all the things. Guys, this is Fraser. Uh, he is with Universe today, and you can see he's kind of. I have to adjust. It'd be nice. I need to get a. They have these cool streamer deck things that I need to get. I, no. Let me see here. There we go. You see? Can you see what I'm doing here?
Yes.
Okay.
And I should have been more organized about this. I had a file I wanted to send you. What's the best way? Should I email it to you?
If how big is the file?
They're little JPEGs.
Oh, you can send it through Discord.
Okay, let's do that.
Yeah,
All right.
Discord's good for that.
Okay.
While you're doing that, do you want to tell everybody who you are?
Hi, I'm Fraser Cain, publisher of Universe Today, co-host of Astronomy Cast, and the host of the wildly popular Guide to Space video series on YouTube. I live on Vancouver Island with my wife, 2 children, and dog.
And dog. One dog? Just one?
Just one dog.
Just one.
One dog now. The other dog passed away a couple of months ago.
Oh, I'm sorry to hear that. Everybody's calling you Dr. Fraser.
Not a doctor.
But you guys, you're very kind. Everybody is very, very sweet here.
No, I am not. I have the same. Let me just grab the Popo chat so I can see people's comments. I have the same education background that you do.
He's a computer scientist.
Also a computer scientist
that loves astronomy.
To call me a computer scientist is a stretch because I have a computer science degree, but not and have worked in software for many years, but I've really been doing this job for almost 20 years. So
yeah. So we're very similar in that I don't want to be called a computer scientist either. I don't feel like I'm sciencing computers at all.
I can't believe I'm going to ask you for some technical support here, but man,
what?
I'm sending you this image. So here's what I wanted to do is that I've been mentioning this, and we were going to sort of figure out some way to collaborate. Is we've got this robotic telescope, this remote telescope, fully operational. I've been using it several nights here on Twitch, and I've been taking some really amazing pictures. And I wanted to send you a couple of the pictures that we've taken so people can sort of see what's coming out of this telescope.
Yeah, and is it not working with Discord?
That's why it's possible that I don't know how to do things.
So you add so on Discord, there's this little plus sign in the message box, the dialogue box. Yeah.
Got it. All right. Hold on. Okay. I see it now. So let's see if you can make these. I don't know if I can do multiple.
You can. I think.
Right.
Yeah.
Right. So now I'm going to upload them and upload them.
There they are.
And then maybe you can share them.
Yeah. Then we can open them. Whoa. Wait, you took these?
Mm-hmm. Gets better than that. Yeah. So this is Andromeda M31, which is the big galaxy that's going to be coming towards us. That's a 120-second exposure. That is a 2-minute exposure. I could do 30 of those an hour.
Holy crap.
Isn't that crazy?
It's so pretty.
I know. And the field of view is gigantic.
Yeah, I can see that.
Yeah.
FOV is wow. I mean, this is wow.
Yeah.
What is the other one?
It is people are asking me what kind of telescope it is. It's like a 150 millimeter apochromatic refractor. It's a monster telescope. It's set up down in Landers, California, thanks to Oceanside Photo and Telescope. And I get to use it as much as I want. And so I wanted to share this with your viewers. So some night we should figure out a way for you to join, and let's do some telescope streamery. So look at the other one. So that's Andromeda.
Well, someone asked how far away is it? So Andromeda is about 2.5 million light years away.
Yeah. And so that is, and so what's important, I think, for people to understand is that this is a crappy picture.
Even though it's okay.
Right?
Well, sure. I mean, I would.
Right. What's possible? It's a crappy picture for what's possible, right?
Right. This is true.
It is a 120-second exposure. It is like when you see pictures of space on like your Instagram, and astrophotographers are doing a really good job. They're doing hour-long exposures, 5-hour-long exposures. They're taking a whole bunch of pictures and they're stacking them up and they're producing this really amazing picture. And so the thing that's amazing is that we're doing these just super quick and dirty, and it's super fun. So, and let's see if I can do one more for you.
Well, we have this one. Do you want to tell everybody what this one is? It looks like a nice globular cluster.
Yeah, that's M13, which is the close, sort of one of my favorite bright globular clusters in the sky. So, just the one. Sorry, and
who is
I
the
apologize.
guy?
I got a bunch of screens. I'm looking up.
You're totally fine. Durwheel, this is Fraser.
This is Twitch. People are patient here.
They are. They're extremely patient. They have to deal with me.
Yeah. So people are asking, like, have I been doing Twitch? Yes. I've been doing this on Twitch. So let's see. Oh yeah, here we go. This is awesome.
And I will share these guys in our Discord too.
It's just Fraser Cain. Let's get closer. Well, let's get closer. All right. Here we go. So the next one I'm going to show is the Ring Nebula, which is again one of my favorite objects in the summer night sky. So
let's open that one up. I don't see that it's sent yet.
Hold on. Sorry, I apologize.
No, you're totally fine. I'm sorry.
I wasn't expecting to do this, so I'm
this is awesome. No, people love this stuff.
And then we'll get on to space news and all that stuff that we normally talk about.
No. This is great. Like, and again, like this is super cool because I mean, you can even see the color differentiation. Like you can see. Yeah. Well, I can. I don't know how many people in chat can.
I'm seeing it on the Twitch, and it looks good. So a couple of people are asking me about Saturn and Mars and things like that. And this telescope is really good for doing deep sky objects, but it's really bad for taking pictures of planetary. So I've asked Oceanside to attach a planetary telescope to this same setup. So you probably want to zoom in on that. Can you zoom in on that?
I can do the fancy Control Plus. But is that the Ring Nebula?
That's the Ring Nebula, yeah.
That is beautiful.
Isn't that amazing?
This is a planetary nebula, guys.
Yeah. So this is a nebula like our sun or star like our sun that died and puffed out its outer layers into space and is cooling down. So so we just do this. We just I just take requests. I'm like a DJ for space, which is really fun. So,
space DJ.
A space DJ, yeah. What do you want to see now?
This is amazing.
Galaxies? Yeah.
Disgusting. Someone killed that sun. Well, this is kind of like a future image of what our sun. They all look different. Planetary nebulae come in all kinds of varieties. But this is a really cool one.
Yeah. And so we just bring up stellarium, show what objects are visible in the night sky, and then just noodle around and take some pictures and explain the science and the sort of moving back towards the days when we used to do these star parties. So this is the foundation of the star parties.
The Andromeda one is amazing.
Yeah, isn't that amazing? Again, I know it looks fantastic, and it is just such a slow, such a short exposure. I can't even imagine what would be possible if it went and took several hours of imaging. So I'm really excited. It's a great gadget for being able to show whatever's up in the night sky.
Yeah, and is this the triangulum over here?
No,
Which one's that?
I forget the number of that. It's just a satellite galaxy of Andromeda.
Okay, because isn't the triangulum getting? I mean, it's pretty close, right?
Triangulum is nearby, and I've taken some pictures of it. It's a little lower in the sky right now. It's a little harder to get early on in the evening, which is I'm such a lightweight, and so I can't stay up all night and do the astronomy side. So So you did have your virtual star party test, right? Well, yeah. So what I've been doing on Twitch is just running this telescope and trying to turn this around as quickly as humanly possible.
And that's amazing. So, thank you so much again for working on that, because this is something I cannot do.
Well, like I said, let's do some kind of collab some night and have your folks show up, and we will set up the telescope.
Absolutely, yeah.
All right.
Yes.
So space.
So space, yeah, we were talking a lot about the solar, the Parker Solar Probe, because that's launching on Saturday at 3:30
Yep.
a.m. Eastern Daylight. Um, so yeah, are you excited about that one?
Oh, I'm super excited about it. I did a video on it. I don't know if you showed it. But
Probably will
uh,
today.
we've got one of our photographers is actually at the launch. And so he's set up a bunch of remote cameras, built like this crazy Arduino system to be able to set up a remote shutter. And he's able to set up his camera system where the journalists get to be really close to the launch facility. And so hopefully he's going to be giving us a bunch of pictures of the rock, those really great pictures of the rocket taking off, and all the flames coming out and all the Mach shock waves and stuff. So we're going to have really good coverage of the launch. But as a mission, yeah, it's an amazing mission. And it's what's really impressive is just how hard it is to get close to the sun. People don't realize that the sun is the hardest place in the entire solar system to get to. Right? The only way that you can get to the sun is you have to cancel out the Earth's orbital velocity going around the sun at 30 kilometers per second. And if you want to go like escape velocity from the Earth, or if you don't even just go into orbit, you need to go about 8.5 kilometers per second. So you need to go so much faster to get to the sun. And so in order for the Parker Solar Probe to get this close to the sun, it's having to take this really complicated series of essentially gravitational slingshots to be able to make to get into orbit, or and get really close to the sun. It's very complicated and quite amazing that they've been able to do this. And I can't even imagine what those pictures are going to look like when it gets that close.
Oh, I know. Like this whole thing, this whole mission. I mean, I've been talking about it, probably for a little bit over a year now. But yeah, because there's so many things about our own star that we don't understand. And again, why the corona, is hotter than the surface. And even things further in, obviously, there's a lot of people that ask all the time. I'm sure you get this too. Like, why don't we understand what's happening really within the sun?
Yeah.
Well, that's because we can't go in the sun.
It's hot.
Yeah. Can we destroy our star? Someone asks.
Well, I mean, there's no physics reason why we couldn't. It's more of an engineering challenge, right?
Build it, guys.
Yeah. I mean, so what do you do, right? There are actually a couple of ideas on how you could do it. It's this concept called stellar lifting. And the sun is already blasting out material into space via its solar winds and going out into the solar system. And so you would just need a way to accelerate that. And one idea is that you would fire a laser at the sun and you would heat up little chunks of the sun, and it would cause it to give off more solar wind material. And then another idea is that you could set up some kind of magnetic fields near the poles and extract material off the sun. And if you just extracted enough material off the sun, you would turn it into a red dwarf star, and keep going. You turn it into a brown dwarf star, and eventually you just turn it into a planet like Jupiter.
And someone just asked, so can we build a star then?
Well, so then once you've extracted all that material, pile it all up and get enough of that material together, and it'll turn it into its own star. In fact, the way to make the sun, because the sun is heating up and the sun is going to die within the next, we showed that nebula in the beginning, the sun's going to die back in the, 5-7 billion years from now. So instead, let's tear the sun apart using this technique, turn it into 13 red dwarf stars. They'll all last for 10 trillion years, and we're set. Now, David MMO is asking, why can't we just throw the stuff into the sun to incinerate it? Would that cause any problems? So the problem is, as I mentioned, hardest place in the solar system to get to, right? It's easier to get to Alpha Centauri than it is to get to the sun. So in terms of the amount of delta V that you would need to do. So that's the big challenge, is that it's just pretty much impossible to put any meaningful amount of material into the sun. But if you could, the sun could gobble that all up and be fine, right? The sun has more radioactive substances in it than the Earth will ever generate. So don't worry about the sun. Sun's fine. Sun can handle that.
Yeah, and so someone said asking again, and sorry if I don't get to it right away. I tried my best. Why not launch our toxic waste, trash, etc. into the sun to incinerate it? Would it hurt the
Yeah.
sun, cause problems?
Yeah, so that's what I just answered. So no,
Right.
no problem.
Oh,
Sun
I'm
can
sorry.
handle it. Yeah, and the it's this idea of that people just don't understand that the sun, that when we look at the solar system, we imagine that the sun is this, is the center of the gravity and everything just rolls downhill into the sun. But the reality is that everything that exists in the solar system is orbiting around the sun at very high velocity. And the only way to make them go into the sun is to cancel. So the sun really, if you imagine it properly, is at the top of a mountain that is the hardest place to reach. And the only way to do that is to climb that mountain, to climb that cancellation of orbital velocity to get things into the sun. And
Yeah.
if you want to play Kerbal Space Program, I defy you to smash a spacecraft into the sun. Go ahead. I bet you
No.
can't do it.
But can Scott Manning do it? I'm sure he could.
I think Scott has tried to do it with gravitational assists and ridiculous rockets with multi stages, and all its job is to get something into the sun. I think he can do it.
Hyperblast did ask right before that. Sorry, I got hung up on like because that is the really impressive thing. It's that it's super difficult to get there, which you wouldn't think. But someone said so. Hyperblast said I heard that if you want to get to the sun, you'd have to go somewhere near Pluto.
So that is the second way to get to the sun. The one, if you want to just do it with raw brute force, you just cancel out the Earth's orbital velocity, that 13 kilometers per second, and then you just fall into the sun. Nice work, you did it. The other way is that you can do essentially do an orbital trajectory around the sun where the ellipse is so flattened that one of the points of the ellipse passes through the sun. And essentially, if you can go about 16 kilometers per second, then you just shy of escape velocity from the solar system, you will take this really long pathway out of the solar system, and then you'll come back in and you'll smash into the sun. So that's plan B, is to attempt to almost to escape the solar system and then come crashing back into the sun. So you want to essentially turn your orbital velocity around the sun to zero and then crash back in. Good
Yeah.
luck.
And so everybody's saying we're all debating now where we throw our junk. Master Coupon definitely says throw it at Jupiter.
Every option that you're going to have to get rid of your junk in space is just going to get more expensive than the last. If you want to look at a piece of garbage, like imagine weigh this week's household trash, right? Like what is it? 5 kilograms, 10 kilograms. Okay, great. So you're going to have to pay on the cheapest rockets that are out there right now. You're going to pay, I don't know, $100,000 to take your garbage. Just take your bag of trash and put it into space, just in orbit, and then it'll burn up in the atmosphere and be gone, right? If you want to send that to the moon, you're going to need about, say, $1 million to take your household junk. And then if you want to send it to like Jupiter or Mars, then you're looking at, say, 5 million, 10 million. You want to throw it into the sun, you're looking at easily billions of dollars to get that garbage into the sun. So I'm just saying, maybe if you're looking to maybe make less garbage or recycle it, reuse it. Yeah, like there's some cheaper ways to deal with your garbage than to try and fire it into space.
There are still people that don't recycle.
Yeah.
There are still people that do not recycle. I don't even know. Yeah. I've witnessed people doing that, and I'll watch them just throw a plastic bottle in the trash, and part of me dies. So I pretty much have a no soul, nothing left.
Yeah. I mean, it's not like space doesn't have room for it. Like, obviously, space absolutely has room for all of our garbage and more. It's just that we can't afford to put our garbage into space.
Where's the fun in that? Wait, is someone actually advocating in here that we have like a space garbage chute?
I get this question on an almost weekly basis. and so I did a video about this on my channel. And again, I just don't think people understand how expensive it is to fire things into space and how difficult it is to do. So I use it as an opportunity to teach people about orbital mechanics and space flight and things like that, and to provide history on launch failures. Right? You really want 10 metric tons of radioactive waste detonating in the atmosphere? I don't think you do. I don't think that's what you
No.
want. And that 1 in 100 of them are going to do that. So anyway,
Yeah.
that's but it's these misconceptions that you want to sort of help people understand. It's people wonder why the sun can't handle the waste, or the sun can handle the waste, or people are worried about turning Jupiter into a star, right? So that kind
Yeah.
of stuff. It's fun.
Yeah. But like, turning Jupiter into an actual star, I mean, that's going to take a lot of mass and
Just another 77 Jupiters.
yeah, just like
Like you can totally turn Jupiter into a star by
Yeah.
crashing things into it. All you need to do is take one Jupiter,
Mm-hmm.
crash another Jupiter into it, and then another one, and do that 77 more times, and then you'll have enough mass
Right.
to make a star, the smallest possible star.
And I'm going to refer to you for you have an awesome thing that you said in the stream a few streams back where you said how much of the asteroid belt
Yeah.
is the mass of our solar system or something like that. I think you gave a figure on that.
Yeah, that that if you take the entire asteroid belt and you mash it all together, you get an object that has 5% the mass of the moon.
Right. And that's the whole asteroid belt.
Yeah, so that's not a planet. That's just an asteroid.
Right.
Like a really big asteroid. 5% of the moon.
5%. And it's funny. I was thinking about that the other day because we were talking about something with the moon, and I wanted to reference that, but I didn't want to botch it. Someone just said, "What?" Yeah. All the objects out in the asteroid belt. If you were to just bundle that up, crunch it up, you'd only have about 5% of the moon.
Yep.
How do you move Jupiter-sized objects?
What?
Not easily.
I just told you what the recipe was. I didn't tell you how to actually do it and where to find them. So, that's your problem, not mine.
Yeah.
Let's give you the recipe.
Someone did ask another good question though. So couldn't we hitch a ride on a comet to the sun?
Well, okay, so here's the thing, right? Like a comet is going on a trajectory, or a comet is going on an orbital trajectory around the sun, and some of them are even falling into the sun. But in order to land on a comet, you have to be able to essentially match the trajectory that the comet is going. And if you've been able to match the trajectory that the comet is going, then you don't need the comet. Let me give you an example, right? Let's say you're driving down the highway and or you see a car driving past you on the highway and you want to jump from your car to that car because you like how fast that car is going. So all you have to do is get your car going fast enough, the exact same velocity as that other car, and then you jump from your car to that other car. But if you were able to do that, then you don't need that other car in the first place because your car can do it. So same situation.
I like that. Well, let's just imitate the comet.
But there are some advantages for sure about being able to actually get onto a comet like that, which is that you can get access to the resources on the comet. You can dig in, you can use the water and the dirt and the rock and all those volatile chemicals. So hunkering down on a comet that's on its way to another star system is actually a really smart idea.
Master Coupon says you could put the trash in front of the comet so it crashes into it.
Yes, you can. So that's exactly right. If you fired off your trash on a trajectory that put it exactly in front of the comet at the right moment, the comet will smash into it and carry it into the sun.
Yeah.
So I think that solved it.
I solved it.
You did it.
Got him.
You did it. I will pass along your feedback to NASA, and then you only have to spend the $1 million to send your garbage bag into space as opposed to the $10 million.
We are geniuses. So STC says if you jumped on a comet, would you have moon gravity or just launch away? Well, it depends on the size of the comet. Now, you wouldn't have anything near moon gravity because that's...
you would easily put yourself into escape velocity jumping off a comet. Like pretty much every comet that's ever been seen, the escape velocity is a couple of kilometers per sec. Sorry, a couple of meters per second.
Yeah.
A few kilometers per hour. So you could easily take a bad step and just float away from your comet forever, which is one of the challenges.
It's a scary jumping castle, guys. It's
Yeah.
the
Yeah, no,
moon.
you land on a comet to mine it, and you hit it a little too hard with your hammer, and you float away, and you can never come back.
Yeah.
So just you got to be careful.
Yeah, comets are substantially smaller than the moon. The moon has about a third the surface gravity of Earth.
Yeah, it's funny. People ask, like, could you jump off the moon if you could jump really well? But the escape velocity from the moon is like 2.5 kilometers per second. So
Mhm.
even the most powerful gun, the fastest gun on Earth, if you fired that off the moon, which you could, the bullet wouldn't even escape the moon. So there's just no easy way. Now it's way easier to get off the moon than it is off the Earth, but still, the gravity is pretty significant on the moon.
Rosetta was sent to a comet. They landed on it, but I never figured out what they learned.
Yeah. Yeah, the Philae lander. This was the lander that landed
Yeah.
on Comet 67P. Cheremovich-Gerasimenko. You
Bless
only get
you.
one of those per episode. And so it released this little Philae lander down to the Comet 67P, and there was two problems. It was supposed to have this harpoon system that was supposed to allow it to land, and these retro thrusters were supposed to let it land, and they both failed, and so it landed on its side, bounced a couple of times, and they lost contact with it. They've since found it, but were never able to really communicate with it and do all that close-up science that they were hoping for. So landing on a comet is hard.
Yeah, an asteroid, like that's what I've been telling you guys. Those can be either very loosely packed, which there's different types. But it's sometimes they're not. I wouldn't trust landing on something like that. The harpoons are never gonna work. That's what someone just said.
Yeah. The harpoons were gonna work. They just didn't work.
Yeah, they just didn't.
Yeah.
You
right.
kind
It's
of
not that they won't ever work. It's that they just didn't work this time.
right.
Space is hard.
Space is real tough.
Yeah.
I saw. Wait, let's see. That's okay. And Philae finished the primary mission.
Yeah, well, I mean, the whole thing of Rosetta definitely finished its primary mission.
Mm-hmm.
And actually, the European Space Agency just released this gigantic repository of images. They finally released 100,000 images onto the internet, and they're amazing. And you can access, because the European Space Agency didn't release their images in the way that NASA does. They kept a certain chunk of the images just for the scientists in the beginning to have some time to work with them before releasing them fully. And so they just fully released the entire archive, about 100,000 pictures from Rosetta on their website. So it's a bit of a brand new gold rush to go through them and find some really cool pictures.
I'm still surprised that they could locate the lander. That was pretty crazy. I didn't expect that.
Yeah, it was a real challenge to find it, and the image is pretty grainy. I'm sure, I don't know if you've shown it, but it's this tiny little lander on its side.
Yeah.
Sad trombone.
And the object that landed on looked like a rubber duck.
Yeah.
Rubber ducky.
Yeah. Well, a lot of these asteroids and comets are having these unusual shapes that are the way they're forming, that they're spinning, like the one that Ryugu, which is reached by Hayabusa 2, looks like a little space diamond or 10-sided die.
Yeah.
And you're seeing this shape quite a bit because they're turning, and they're just amalgamations of rock and material, and other ones are different shapes as well. So we're really starting to see that these different asteroids are getting these different classifications. It's pretty exciting. We need to see all the asteroids.
Yeah, we do definitely. And this is a random question. This is a little bit off topic, but this is what this is for. So if you guys have off topic, just shoot your questions. So do you believe in aliens?
Do I believe in aliens? So my position is that there is insufficient evidence for aliens so far. So I don't believe that any of the evidence that people think are aliens are actually aliens. I think there's definitely things that are unidentified, and I think there are things that are flying, and I think there are things that are objects, but I haven't seen any evidence that makes you say, oh, that's definitely aliens. So you can just say it's a mystery.
Mm-hmm.
Mystery. I don't know. What is I saw a bright light fly through the sky
right
last night. Was it aliens? I don't know. Maybe, but until we can actually get close and look and stop the object and open it up and see inside and shake hands with the aliens, we can't say what it was. So, and so far, nothing has been found that makes me go, "Oh yeah, it was totally aliens." It's just, wow, that was totally unidentified and also flying, and an object. So,
Yeah.
do I think that there are aliens in the universe? I don't know. I wish, I hope. It's weird, super weird that, and I know you were going to have me and Paul Sutter
Yeah,
have
we're still
an
gonna have
argument
to
at some
plan
point.
that. Yeah.
Yeah, about the Fermi paradox, and I'm reading a great book about it right now, actually, which is sort of Christmas Day for me to open up.
Well, we won't
about the Fermi
tell
paradox.
Dr. Paul that you're kind of studying up on it.
Yeah. So he's gonna have to bring his A game. But yeah, for me, this idea of the Fermi paradox is so compelling and so weird that I find the answers really troubling. And I always say that anyone who it's this idea that the universe is big and the universe is old and the Earth is relatively new compared to the rest of the universe, and that life formed on Earth the moment pretty much that it could. Why don't we see other life in the universe? And obviously your first instinct to say, well, stuff's really far away from each other, so why would we even know to be able to see it? But there's no reason in the laws of physics that wouldn't allow aliens to be able to move from star system to star system. And we're preparing to do that, right? We're preparing to build self-replicating robot probes that will go to other star systems and dismantle asteroids and send more probes. And so then the question is, why haven't we seen any alien probes? That there are these ideas that in the future we will start to gather more and more of the material from the solar system, the light from the sun, and we should be able to see evidence of that out there in the universe. We don't see it anywhere in the Milky Way. We look at Andromeda and we don't see an alien civilization using up the resources in Andromeda or any galaxy at all. And so it's this really, really weird idea that maybe we are the only advanced civilization in our observable universe. And it's this really big, troubling idea. And I find it really fascinating to think about. And right now, one of the things that was really interesting, I had a chance to interview Brad Peterson, who is the chair of the committee that's developing this next generation telescope. And I know you showed my videos a couple of weeks ago, and the one is LUVOIR, which is sort of the dream telescope, right? It is this 15-meter space telescope like Hubble, but instead of 2.4 meters, it's 15 meters in space. And one of the things that LUVOIR will be able to do is tell us with 90% accuracy if we're alone in the universe. Yes, please.
Yeah, no, that'd be really, really cool. Yeah.
Wouldn't that be great? So it will be so powerful that it will be able to analyze the atmospheres of other planets around other stars and determine if they have life on them to a volume of space around the Earth, to the point that we know that answer to a 90% level of accuracy. So if LUVOIR gets rolling, examines this volume of space around the Earth, we could say we are alone in the universe. So, and this is a telescope that's in development right now and will be hopefully built by the mid 2030s.
Oh man!
And there
I'm feeling old with these dates.
I know, but don't worry. There are telescopes that are being developed here on Earth right now that are almost complete, that will do a pretty good job of that as well. There is the European Extremely Large Telescope that's coming out in 2024. There is the 30-meter telescope, which I think is around the same time, and the Giant Magellan Telescope. And all three of those are going to be built in the next 6 years. And those will also be able to do a very similar job in answering that question.
Well,
right? Maybe not 90%, but maybe it'll be 70%. So within a decade, we will know to a significant level of accuracy, probability, if we're alone in the universe, which is a stunning question.
Well, yeah. So James Webb Space Telescope is going to be able to analyze atmospheres and
same job. And so you're seeing all these telescopes come online, and they're all going to have this capability to go look at planets around other stars and find out if there's life there. And of course, you've got to imagine the aliens can do this to us, right?
Mm-hmm.
That if there are aliens around those other planets, they can look at our star system and say, oh, there's life there, right? By our pollution, by the oxygen that's being pumped out by trees and things like that.
Mm-hmm.
So people always say, oh, we shouldn't be sending the Voyagers out to space, and we shouldn't be transmitting our existence to the universe. But the reality is that any aliens that are out there who have built telescopes about as powerful as we can know that we're here.
Yeah, you could just look at our atmosphere.
Just like, hi. as you drive your car,
right.
as you breathe, you're telling the aliens
you're
that you're
outing
here.
yourself. You're exposed at that point. So good job.
And they could have done it for about, Crimson is saying, aliens could have done it a billion years ago, right? They could have done it for the last 500 million years or so. As soon as oxygen got rolling here on Earth, aliens in the Milky Way have with powerful telescopes have known we're here.
Yeah, and I mean, well, there was a point, obviously, during Earth's, earlier phases of life where there was too much oxygen. But
and it could only have been produced by life. And so, to a certain extent, I mean, there are processes that can do this naturally that don't require life, but still, powerful alien telescopes know we're here. So then again, where are they? Why haven't they been communicating at us with radio waves, which they would assume we have developed because they know that we have combustion engines now?
Right. Well, DPI raised a few good points here. The last one was hopefully it's not Northrop. I'm okay, so I'm going to skip past that one. But as far as the development of these telescopes, but the thing he said is that Andromeda is 2.5 million light years away. So if they did notice us, it would take some time. Right?
2.5 million years ago, sure, Andromeda. Mm-hmm. But what about Alpha Centauri, which is only 4 light years away? 4 years ago.
Right.
They don't know who won the most recent U.S. election, but they know who won the one before.
Yeah, they're probably better not knowing, but it's okay. So why would aliens have the same technology as us? That's actually not a bad question.
No, I mean, so all of our assumption is that aliens live in the same universe that we do, that they have to use the same laws of physics that we do, that there is energy and there is matter, there are atoms, that life would have gotten a hold in some other world, and it would have the radiation from their star and the carbon atoms and silicon atoms and all that kind of stuff to use. And so we don't know exactly what their technology would look like, but they would still be limited by the laws of physics in the same way that we are.
Mm-hmm.
Unless there was some simple way to find other laws of physics that we just didn't catch on to. But it seems weird that would be possible. So there are certain assumptions. When you think about aliens, these are some of the assumptions. And the one is they have to use the laws of physics.
Mm-hmm.
They can't use magic.
Yeah.
Because if they use magic, then all bets are off, right? Then nothing matters.
And someone did ask, for distinction, and that was I think it was Hyper who asked earlier. So I did see that Hyper. He said, so are we talking about AI or, not AI, I'm sorry, intelligent life, or are we talking about microbial?
Well, right now we have no evidence of either one.
Right.
So, but the whole point is that a telescope like LUVOIR will give us evidence of some kind of life. It's this term called biosignatures, and it is essentially a gas that is present in the atmosphere of a planet that is out of balance. Mm-hmm. So a good example of this is methane, right? If you measure the atmosphere of the Earth and you measure all this methane, it can only be produced by farting cows or burping cows, mm-hmm. right? Only burping cows can, and methane is broken up by by ultraviolet radiation within like 100 years. Mm-hmm. And so if the cows all disappeared, then about 100 years from now, all the methane would be gone. And so if you detect this methane in the atmosphere, then it had to be generated by some kind of life form that was producing. It's out of balance. And so astronomers are going to be looking for these out of balance chemicals in the atmospheres of other planets, and then use that to say, okay, this one has life, that one doesn't. And then some of the really interesting out of balance ones are technosignatures. So chlorofluorocarbons, which are a thing that, refrigerants, there's no natural process that will produce these. you need advanced chemistry to be able to do it. And if we build telescopes that are powerful enough, we could detect the technological signature of other species around other star systems. And so someone was mentioning, you can only do this via the transit method, but that's not true anymore, right?
Mm-mm.
The transit method is where you can see the star and the planet passes right in front of the star, and then that tells you that you can analyze the planet. But these next generation of telescopes have coronagraphs on them. They can block the light from the star, and they can take pictures of these planets going around these stars directly at any angle. So it's not just the ones that are lined up anymore. They'll be able to just take a picture of a star system and then see the planets. It's going to be an amazing time.
Yeah, and so you're absolutely right. So the transit method, it can give us details like the properties, like is that a denser planet or is that a gaseous planet? You can also get the mass, but getting an atmospheric composition is super tough.
Yeah, well, and the radial velocity method, where you measure the how the star is being yanked back and forth by the gravity of its planet, is one way, and you want things lined up towards you, right?
Right.
And then the transit method is the other way, and you want those lined up. But those are just two of the probably dozen different ways that have been proposed to detect planets. And gravitational microlensing is another way, and that doesn't require things to be lined up. So in the same way, so we are entering this time. We have all these really rudimentary ways of finding planets today, but as these new next generation telescopes come online, they're not going to need these old school ways of doing it. They're going to be able to see stuff directly and with other technology as well. So we are it's going to be an amazing time as these new telescopes get online. And LUVOIR would be wonderful, but again, within the next 10 years, you're going to see these gigantic Earth-based telescopes with really powerful techniques to be able to essentially disappear the atmosphere.
Yeah. Someone said the Earth took like 600 billion years. I know it's not accurate. Yeah, not 600. Our observable universe is around 14 billion. The Earth is
but 600, like 500-ish million years. Like, it's amazing how quickly life formed on the Earth. The Earth has been around for 4.5 billion years, but yet within the first 500 million life started to form.
Yep.
Yeah, so not billion, but million.
Right. So you're not wrong. I mean, it's okay.
Just drop 3 zeros off your estimate.
And it's totally fine, because I'm pretty sure the day before, I said that the Gaia mission preceded the Hipparcos mission, which I meant to say succeeded.
Yes. Did you make a mistake?
Maybe. A small one.
That's the worst.
I know.
Can't believe it.
I thought I've been thinking about that that's already gone through my head maybe about 6 or 7 times just on today's stream. Like, man, I just...
Like how badly you made that mistake and how people called you out.
Nobody said anything.
You're never going to be able to recover.
Nobody said anything.
Oh, wow. No. Man, I would say that one of the things, like, you doing these live streams and talking to people and giving people this feedback in real time and getting feedback when you make a mistake, is really valuable. And I know it is just crafting your brain into this finely honed weapon of science explanery.
Yeah, so, that's just it. Like today we were talking about solar flares, the difference between a CME, a solar flare, solar wind. Prominences, which are filaments, things like that. And I'm sitting here explaining, I'm basically testing them to see, like, what do they know? And is this making sense at all? And with their feedback, be like, so isn't it this? And like asking the questions, and I can communicate it, or try to maybe next time because you walk away from these kind of things just being like, well, I should have probably outlined that better. I could have done a better job at describing that. So it is really cool. I do like that aspect.
And the more time you do this, the more you come up with your standard ways of explaining these things, and you make less mistakes. And so don't worry about making those mistakes. All they do is make you better.
Yeah. Science explainer. Put that on a t-shirt. We should.
Yeah, no, a finely honed weapon of science explainer.
Yeah, no, it definitely, it works.
I forget. Yeah.
So let's see here. So someone says, so these kind of starts also happen in different planets 600 million years ago. So these kinds of starts can also happen in different planets 600 million years is very small.
Right. And so when you think about the age of the universe, if the universe is 13.8 billion years old, and the our solar system has only been here for
5-ish.
4.5 billion years.
Yeah.
Then the universe was around for 9-ish billion years before the sun even showed up. And there were definitely stars and there were definitely planets. So there have been probably 5-6 billion years that alien civilizations could have come and gone, and any one of them could have fully colonized any one of those galaxies out there, and yet we see no sign of it. So it's weird.
It is.
Makes you ponder.
Compared to human tech progress, a comparative alien civilization would only need 500-year head start.
Yeah. Right. That's all you need is just 500 years. Think about where we were 500 years ago and where we are now and our technological capability. Think about where we would be in 500 years from now and how that would compare to us.
It'd be insane.
And so a 9 billion year head start, that's a lot of time.
Why do I think of the movie WALL-E when I think of about 500 years from now?
Because you think that the Earth is heating up and is going to turn into this cross the tipping point of climate change filled with garbage and global warming.
Yep, we have to go on a spaceship to live.
And we have to go on a spaceship? Yeah.
And people are driving around in mobilized shopping carts.
Right.
Not having to do anything, and with all of the consumerism available to you.
Yeah, so someone's mentioning here, like, are you saying that we'll reach a type 3 civilization in, was it 500 years? We'll hit a type 2 civilization, I think, in about 2,000 years. So we will have built a Dyson sphere around or a Dyson swarm around our star in about 2,300 years.
Triggered.
So
I'm triggered.
Sphere triggered? Swarm triggered?
Swarm and sphere. Because Dyson's a vacuum cleaner, I'm pretty sure.
Oh, yeah.
No, I get that question. Everybody's like, what?
Yeah. So if you look at the amount of energy human beings have used since we first started using energy, and you just make that a curve, and you just follow that curve into the future, just right, like, who knows what we're going to do. The joke that I always make is, like, maybe we'll be able to, like, play The Witcher at its highest screen refresh. So who knows what we'll do with all that energy. But that curve of our energy just proceeds perfectly from the beginning, when we first started to, like, light fires, to agriculture, to steam power, to hydroelectric, to nuclear, to our current day. Just map that out and you will hit the entire energy output of our sun in about 2,300 years from now. But
first you got to stop. People have to stop buying Hummers, guys.
What? No,
if we want to be around,
Hummers for everyone. Hummers will drive your Hummers.
No, don't.
Right?
Do not clip that. Nobody clip that. That's going to be taken so out of context. No, what I mean is, like, if we won't even be around at that point, I don't know if I really see humanity with the way things...
Maybe you, but I'm going to be in my third robot body.
Oh, man. Yeah. Sorry. That guy tried to get that in twice. I got him. Oh, no. That was a misclick. Emperor Sauron, that was a misclick. Don't worry, faking you. You're fine. You're totally good. Yeah, that happens.
So, yeah. So the point is that we don't know what we're going to use that energy for, but if we assume that we will continue to use more energy like we have in the past, we will hit Dyson swarm by 2,300 years. And we would, if the speed of light wasn't a problem, we would hit a type 3 civilization. We would have installed Dyson swarms around every single star in the Milky Way in about a million years. Yeah. That the speed of travel is the problem. And then let's say we're going to go 10% the speed of light, we will have turned every single star in our entire Milky Way into a Dyson swarm we could do it a lot faster if we didn't have to travel at the speed at less than the speed of light, but we will get there probably in a million years from now. We will have enclosed every single star in our entire Milky Way with, or if we fail to do it, then the octopuses will do it, right? You know, the next civilization will come along and they'll do it, or the dolphins or whatever, right? But that's what life gets you, and that's what exponential growth gives you, is Dyson swarms everywhere.
Right. And oh man. I mean, you're just the amount of material that would be required to make something like that. Right?
Well, what do you mean the amount of material? Well, so the point is like the idea of a Dyson sphere is a bit of a misnomer because
Right.
it's not a stable object, right? If you created a fully enclosed sphere around a star, it would no longer be able to be in orbit. It would essentially be free floating and it would just bump into the star and then that would be a problem. So what you do instead is you just build satellites one after the other. You build one satellite that collects solar power in orbit around the sun, and then you build another one, and then you build another one, and then you build another one, and eventually you've gathered every single photon that's coming out of the sun, and that's a Dyson swarm. So
Yeah.
it's not going to be Dyson spheres, it's going to be Dyson swarms. And if you were to turn every single piece of material in the solar system into Dyson swarm, you could have them be about 20 centimeters thick. So no problem. You could collect every single photon that's coming off of the sun.
So only 2,300 years?
Yeah, about that.
Okay.
Yeah.
I again, I'm saying like people just, I feel like we're not being very nice to Earth right now. I hope we would be.
Well, so
soon.
one of the downsides of building that Dyson swarm is we will have to dismantle Earth.
Well,
So,
no big deal.
Yeah. So Earth there will
Pack
be
it
this
up.
probably some little monument somewhere where it'll be like an original piece of Earth, and you like go and you'll check it out and you're like, oh, that's really adorable.
So we're gonna just disassemble it like some crappy IKEA
Yeah.
furniture.
Yeah. If you want to go full Dyson swarm, you're gonna need to dismantle the Earth.
Okay. People are like, worth it.
Worth it. Yeah.
There was another really good question here. Could there, of course, it's Master Coupon. He says, so could there be an end to our practical energy needs? Maybe a point where it's easier to use energy more efficiently than to get more of it? That's a good question.
Well, we right now use more energy than human beings have ever used in the history of all the world. In fact, each one of us now has access to more energy cheaply than was available to the richest people 100 years ago. And so that is what you will see, we hope, is that over time, each person will have access. So in the future, 100 years from now, a person will have access to more energy than Elon Musk. And what will you do with that much energy? You will have your robots make more robots. It's hard to even just imagine what that kind of energy abundance is going to do into the future as we continue to progress. But I guarantee we will figure out a way to use it up. Right?
Yeah.
And so the goal is, like, by all means, like, the sun is throwing all that energy out into space. That's awful. What a waste. Like, don't use it to heat up the atmosphere of the Earth and to make this place bad, but by all means, send up solar panels and harness that energy and use it for things that aren't going to make the Earth more polluted.
Confirmed, Fraser is blaming the sun.
I'm just saying the sun is wasteful. I'm saying the sun, if it wanted to, could direct the right amount of energy into ways that we could then use it, as opposed to just throwing it out into space. I feel that's a little... and it's been doing that for billions of years.
Yes.
Right? 4.5 billion years, the sun has been throwing out all that energy just into space. When it could have been saving it for us, for our investing in it, for our future retirement fund. It's just not fair.
Right. And see, like, if someone says, I blame the atmosphere, I blame both. So the sun is being wasteful. I mean, we talked about that. Just in a solar flare, you can have, what was it? 1 billion H-bombs, in just one solar flare. Just one.
Yeah. Boom. Blasted off into space. How does that help anybody? Right?
Fraser does not. Because it's true, though. It is true. That's a lot of energy. And yeah, our atmosphere is definitely, trapping things in. But,
and in a Google years from now, when the universe has cooled down and all of the black holes have evaporated and every single star is dead and the protons themselves are starting to decay, we're going to wish we'd held on to that material and the sun had held on to it earlier so we could use it, as opposed to shivering beside the dying black holes that were huddled up around.
And everybody probably thought you were just referring to the search engine. He was not, guys.
No. A 1 followed by 100 zeros. That many years into the future, then we'll really wish we'd saved our energy. So don't worry. Then I'll be on to my fifth robot body.
Please, son, give us more bombs.
Yeah, let's stop wasting more bombs. Make the bombs less bomb-like and let us use them so that we can have more power and run The Witcher at high frame rate.
Yeah, and so Crimson just suggested, so we only have a few more minutes, but Crimson said there's a challenge to the universe expansion that came out like a week ago.
Mm-hmm. Yeah. I haven't done a video on this, but I will. But essentially, there are two ways to measure the expansion of the universe. Both of them are incredibly accurate and without argument, and they aren't the same.
So, guys, you have to check out his YouTube. And we probably will too. Like
I haven't done this video yet, but I really will. And,
yeah, he does the interesting ones too. Like he doesn't just go for the normal everybody knows news. He'll actually go through and pick out things that are interesting. And then there's well, did you see the news that I was super happy to see from the Chandra Observatory about the intermediate black holes? Two scientists.
When was this released today?
Yeah.
Oh, no, I haven't seen it.
I retweeted it because I was super excited to hear that because obviously we figure that they have to exist, right?
Yeah.
I mean, they gotta. But seeing that and having talked about black holes, almost every single time I stream, which is totally fine because they're cool.
Yeah. It's absolutely everyone wants to know about black holes.
Yeah, because they're cool. Joe, thank you for linking that, by the way. There's a link to his YouTube, guys.
Fraser's weird news collection, maybe once a month.
It would be fantastic, but he does do a lot of that with his Q&A, and that's why I love the Q&A. And he does, he's able to record that. Where you guys, in that case, like you guys get to see my expression when somebody asks me about white holes or something, and I, get this look of disgust.
Yeah, I just get to point at my video where I talked about white holes and call it a day.
Right.
Before I do go though, let's do some. Let's synchronize our calendars.
Yeah.
So when do you want to join me to do some live telescope observing with your viewers?
We could definitely do that. So obviously it'd have to be dark.
Yes. So right now, anytime after 9 p.m. Pacific time.
Yeah, I think honestly probably not this next week because my kiddo is going to be in that off week before going to kindergarten. I would say the week right after that. Let's see here.
Okay, well, we'll talk about it next week.
Yeah, maybe the week of the 19th, towards the end of that week.
In August.
Mm-hmm. If you can.
That's my birthday, but yes, that'd be fun.
Even better.
Exactly. Okay, well, let's tentatively say then that we will try, and hopefully I'll know how to do this better. So in about 10 days, we'll set up the telescope and we'll just take a few hours and people we'll yak about space and people can request and we'll find out what we can find.
Yeah, and I think if I can definitely let them know. Maybe we can get that on the front page of Twitch too, so they can join us for the virtual star party as well.
Have you shown the virtual star party video?
I have before, but I'm going to show it again. Is it the Google one?
Yeah, the Google one where we sort of talk about how it works.
Yeah, I need that link again. I forget where that was originally. You might have sent it to me in the Discord message.
Yeah, I'll just send it to you right now again.
Yeah, because I would love to show everybody so you guys know what we're doing. I know Twitch they've already said that they would love to showcase this too. So they just need about a week notice.
Here, here, I'll just put the link. It's like 3 minutes long, 2 minutes long. Why don't we just watch it right now?
Okay. I will put it up, and I will take do you want me to take our faces away? Because I don't want people to...
Yeah, take our faces away.
Yeah, I'll take our faces away. So you guys can see this.
And they're going to see like a hilarious looking Fraser.
Oh, let's see. Okay, I'm going to take us away. I'm going to mute the mic real quick.
Okay. And just angle it a little bit down, like towards the line.
Like that? Okay. Fraser loves a rosette, so we always go to that when it's in view.
I love science. I love communicating and exploring about space and astronomy. I want other people to enjoy this stuff as much as I do. My first instinct is always to set up the telescope and go, you look first. So when Google Plus came out, I thought, wouldn't it be cool if we could get a telescope streaming an image right into the Hangout? And Mike's got just this monstrous telescope that he's built himself.
I hadn't even done a Hangout yet. I'm like, this actually sounds really intriguing, right? It's telescopes, it's computers. Let's figure this out, let's try it.
He emailed me and he said, I think I've got it working. And he invited me into a Hangout, and there it was. You know, there was the moon. I was hanging out with the moon. That was when I knew we could do anything. You know, let's get more telescopes, let's get different points of view.
Everyone, this is Umair.
Hi, Umair.
He's based in Pakistan, and then we've got Peter, who is in Australia.
We're getting people from Mexico and South America and South Africa, Malaysia.
Hey, there's Pamela.
Hey, Fraser.
And now suddenly, there's a way with almost no effort, we're able to bring all these people together and put on a show.
Too close.
Everyone good to go?
Good to go.
I'm gonna click on Start Broadcast. We're public in 3, 2, 1. Hi, everybody. Once again, we're gonna have our virtual star party. Working the telescopes tonight, we've got Stuart Foreman. He's the one showing us the moon right now. We've got Gary Ganella. What's your view, Gary?
The monkey head, it's in the upper part of Orion.
That's really
If
cool.
we were looking at this image in color, what we'd see is this is a beautiful red line.
Yeah, it's a beautiful.
Well, I think everyone's ready but Mike.
Here we go.
And no pressure, Mike. Oh, I think I see something. Can you move it a little down, Mike? There it is. Oh, man. Look at that. Don't ever change cameras, please.
Just in being in contact with these people, and just talking to people. Some that you don't know, that you're getting to know, even though they're 3 time zones and thousands of miles away.
Somebody to share with. It's nice when I look at my pictures and know I did it. It's wonderful, but to share it with somebody.
Being able to look out into space gives us context for how we live in our day-to-day experience. It shows us that we're part of this bigger universe.
All right, so Gary, you've got the rosette for me.
I do.
I mean, for us, for everyone to see, not just
Don't
me.
kid us. It's for you, Fraser.
It's for me, yeah.
Now we have Saturn is green. You guys are just into it.
Yeah, that's so cool. So we
There you go.
Yeah, that's amazing. And so he's been so generous, and thank you so much, Fraser, because he's been so generous, and he's going to do this for us because everybody asks me, and you guys always say, you have a telescope and stuff, and it's really difficult because mine are manual, and he has other people, and he has him, and so it's great, and we will be doing that. So I will keep you guys all posted.
Right on.
Yeah.
And so we'll whenever you want. Like I said, I'm trying to figure this out, so I'm sort of there every night on Twitch here.
Yep.
So join me some night if you want, and we'll see you all next week.
Yeah. So thanks so much, and I will talk to
problem.
you soon.
All right.
All right. Bye.
See you later.